Oh, hi there. I didn't hear you come in. If you can't tell, I've been drinking, and I'm starting to notice some funny changes. My movements are off, I'm having a hard time balancing, and I'm getting a little bit mentally slow. Today we're going to use science to discuss the three main mechanisms behind these changes and discuss why my body reacts the way it does to excessive alcohol. Now, if you excuse me, I'm going to go throw up.
Hey folks, welcome to the Lower Limb Lunatics educational video, The Influence of Alcohol on Balance. Let's introduce the crew.
Hey, I'm Ryan.
Hey, I'm Dalton.
I'm Dean.
And Kristen.
By the end of this short video, we're hoping that you will pick up on the three mechanisms involved in balance, that is visual, vestibular, and somatosensory, how these mechanisms are influenced by alcohol consumption, and in turn how the body responds, specifically coordination, speed of processing, and balance. Overall, gait.
Now let's get started with a brief overview on how alcohol affects our balance.
So we all know that consuming excessive amounts of alcohol makes it more difficult to function. It affects our balance, our coordination, our speed of mental processing, and many other things. But for the purpose of this video, we'll discuss how these are connected to our control of balance.
Scientific research using center pressure stabilogram, dual tasking tests, and reaction time tests have shown that consuming alcohol is detrimental to our balance, coordination, and mental processing abilities.
Balance control is heavily influenced by the vestibular system, the visual system, and the proprioceptive system, as well as cerebellar functioning.
Under the influence of alcohol, these systems are disturbed, which causes distinct functional changes that we see in the form of drunk walking and balance.
So the first possible mechanism that could change in response to alcohol consumption is our vestibular system. There are three semicircular canals that reflect our three dimensions of space, the X, Y, and Z axis. This is one of the three semicircular canals. The gelatinous cupula contains position-sensitive hair cells that respond to movement and gravity. Depending on the movement, this information is sent to the brain to maintain proper body alignment and balance in space. When alcohol is consumed, it enters our bloodstream and eventually our vestibular system. The viscosity of the gelatinous cupula lowers before the alcohol reaches the semicircular canals. The difference in the viscosities causes the hair cells to fall to one side and sends impulses to the brain have a constant acceleration or a spinning sensation, yielding symptoms like the spins or dizziness after too many rum and cokes.
In conclusion, alcohol influences how our hair cells respond to gravity and motion, and this affects our ability to stay upright and activate correct musculature, overall balance.
Now on to Kristen for a discussion on the visual system.
The semicircular canals detect head rotation, and they communicate with the ocular muscles in order to control eye movement and stabilize vision when you move your head. The changes in the semicircular canals when alcohol is consumed affects the way you perceive your orientation with respect to gravity. In response to these changes, the visual system is receiving incongruent stimulus from the vestibular system, which causes unnecessary eye movements to compensate for the false sense of acceleration. After alcohol consumption, these eye movements become jerky or shifty, and this is known as visual nystagmus, as shown here. Saccadic eye movements are also affected, as shown by decreased accuracy and slower velocity of eye movements and prolonged fixations. All in all, alcohol influences our control of eye movements, vision stabilization, and causes visual nystagmus.
Now we're going to discuss how consumption of alcohol affects speed of processing. Speed of processing is an incredibly important modality in terms of balance control. The speed at which we are able to process bottom-up or external stimuli determines how tightly we are able to control our center of mass within our base of support. Balance is never static, even when we are standing still, and it requires a great deal of control to make on-the-fly corrections to the center of mass location. However, when we consume alcohol, our ability to process information and coordinate the appropriate neuromuscular patterns necessary for balance becomes inhibited. Alcohol directly slows down the speed of neural processing across the synaptic cleft by altering the permeability of the membranes and the effectiveness of the ion channels. Overall, alcohol reduces the speed of processing, which leads to an increase in center of pressure sway and the number of corrections in dynamic gait, as well as limiting our ability to conduct balance tasks, such as walking in a straight line. This contributes to the stereotypical drunk walking gait. Now on to Ryan for his discussion on proprioception.
Those under the influence have a big decrease in coordination and balance. This is shown by an increase in sway, mainly in the anterior and posterior direction. Increasing blood alcohol content leads to an interference in nerve pulse transmission. This can be caused by blocking voltage-gated channels at nerve terminals throughout the presynaptic membrane and motor end plates. This can act at the muscle level, leading to an increased conduction time of the synapse, leading to delayed postural responses.
After watching this video, we hope you learned a lot about alcohol's effects on the vestibular, visual, proprioceptive systems, and speed of processing.
Thank you.
Thank you.
Thank you.
For watching.